Hey everybody, welcome to CS160. We're in week 4 here, and we're going to start to dive into a bit more complex stuff in the Python side of the class. It's computer programs are really just a novelty if all they do is print out information and maybe input some information and do calculations like that body mass index program. But a program really becomes effective when it starts to analyze information and make decisions based on that information. And so what I'm going to do today is show you some examples of the primary way that you make comparisons and make decisions based on comparisons inside Python. And that's called the if statement. So we'll go through a few of these, and then by the time this video gets posted, the file here that I generate will be available for you to play with as well. All right, so the format of an if statement, sometimes you'll hear these things be called if-then statements, or if-else statements, or if-then-else statements, but they basically follow kind of the English nomenclature of if something is true, then do something. And so in lab 2, I think it is, you learn the concept of Boolean expressions, and you start to evaluate certain Boolean expressions, whether they're true or false. So we're going to do some of that in here as well. So let me give a very simple example. We'll set a value a equals to 10, and we'll say if a is greater than 10, and this is the syntax. We use the statement if, and then we put the expression after the if, usually with parentheses around it to help with readability. And then we put a colon after it. And the colon is unique to, well, I don't know if it's unique, but Python, the colon is required. Other languages use other things. And so if you've programmed in Java, for example, or C++, you'd see different syntax here. And so if a equals 10, then we're going to do something. Now I hit return after the colon, and notice what happened here. And let me do that again so you can watch. So I'm here, and I hit return. And the cursor came to a spot in the next line that wasn't to the very left of the line. It came in indented. And this is really important. Because the statement or statements that are indented after the if statement are the ones that will get executed if the statement is true. Okay, so if I run this program right now, let's see what happens. We're just going to call this thing if.py. And you see I ran it and nothing happened. Well, something did happen, but nothing got printed. This expression here evaluated to false. And so the statement that's indented under here did not execute. So let's try another one. Let's say if a is less than 10. Let's run that guy. Same thing. So now let's try okay, so there are two equal signs here. This is a double equal sign. This is another important point in many programming languages, or at least some programming languages. A double equal sign is a comparison. A single equal sign is an assignment. Okay, so let's run this. And you can see this line printed out. Let's remove these so I don't have those extra spaces. You can see that this line did get printed out. Now, what if I change this back to just a single equal statement? Let's see what happens. I got an error, right? I got an invalid syntax error. We're lucky that Python does this for us. In C and C++, you do not get an error message. And in fact, this will actually modify the value of a if you only have a single equal sign, and it's one of the hardest bugs to find in a C or C++ program. So we're thankful here that Python has this capability, and it gives us that error message. so that we don't forget our double equal sign. Okay, so this is a basic if statement. Let's talk a little bit more about indentation here. If, let's see, yeah. So you can see here I can have multiple lines that are that are under this statement. And if I run this, I don't get either of these lines printed. But if this is over here, let's watch and see what happens. This line did get executed. So you might have meant for this second print statement to be part of the code that gets executed with this decision here. But if it's not indented, it doesn't tie in with that. Different languages do different things. And in some languages, you put like a curly bracket or some other indicator at the top and then at the bottom. Python relies on you using the indentation. The amount of indentation will be basically specified by your editor, right? In idle, a tab, if you hit, see I can hit tab here and it moves me 4 characters over, or I can just do 4 spaces, either way. If you're listening to my keyboard, you can kind of hear that. Either way is okay. All right, so you got to watch out for your indentation. Here's another example here. You can see this line got printed because that comparison's true, but then this line also got printed because it's not inside the indentation, right? So what if I want to do something where I want to basically say, if something's true, do something, else do something else? We have this construct which is called an else. And so I can modify this to say else print no, a is not greater than 10. So what happens here is we evaluate this expression, and if it evaluates to a Boolean true, the items indented under that first colon get executed. Otherwise, or else, the items under the else's colon indented get executed. And so this is your example of what's called a basic if-else. We can add multiple comparisons here, right? So let's say that I want to say, if something, then do something else. If something, then do something else. If something, then do something else. If something, then do something, and so on. I can do that. And I can do that in one of 2 ways, right? And I'll show you one way. This elif is shorthand for else if. So we say if a is greater than 10, print this. Else if a is less than 10, print this. And so nothing happened because in both those cases those seem to come true. Both of those come true. Let me show you another example here, which is important here. So I change this to 20. So this top one evaluates. Now if I change this second one to also be the same, let's see what happens. Only this got printed, even though this is also true. This is also really important because if we read the logic here, it says if this Boolean expression is true, do this, else if this Boolean expression is true. And so that's the key thing about that else. That else only triggers if the if above it is false. Okay, so this is also important because you may have cases where you're comparing things where multiple clauses will become true. And if that's the case, your best bet is to do something like this. Where you just have 2 separate statements here. And in both these cases, we should see both of those printed, right? These are effectively two different sets of statements here. You can also do something like this. And this is common if you're basically processing something and you are doing continuous checks on it based on its value or set of values. You can do something like this. This is called a nested if. And let's run this and make sure this works. Oops, there we go. And you can see that if this is true, then all of this is going to be executed, right? Because it's all indented under this, which means we print this first statement and then we do this if statement. And if this if statement here is true, then we'll execute all of this and so on. This is called a nested if. And you'll find it to be quite common that you have these nested structures where you start to do much more complicated comparisons. All right, in these examples that I've showed you so far, I've showed you checking to see if something is greater than, less than, or equal. Let's do a couple more. Let's do 3 more comparisons. Let's say A equals 10, B is equal to 9. If A is greater than or equal to B. It's less than or equal to B. You can kind of tell what these are doing based on how I say them, right? This is going to be less than or equal to B. Let's change these to both be 10, and I should see both of these should execute, and they do, right? But if I change B to be a different value, say 9, then we'll only see the first one be true. This is how you check to see if something is greater than or equal to. By the way, you can also say this doesn't execute, right? This is if A greater than or equal to B. If this part is true, then the not turns it into a false. And so this whole thing evaluates to false. So if we change this to be a lower number, that should print out, right? So we'll say not A greater than B is the same as A less than B, right? That should make sense intuitively if you think about it in the context of problem. I think it's problem 8 in lab number 2. Okay, and then the last thing I want to show you is this symbol, or a pair of symbols. This is a way of checking to see if 2 values are not equal to each other. And the exclamation mark in a programming language often means the kind of the equivalent of not. Often, not always, but often. And so you'll want to get used to using equal, equal, not equal, greater than, less than, greater than, equal, and greater than or less than equal. Those different sets of comparisons for doing kind of numeric comparisons. These comparisons also work on strings in certain ways, and there's different ways also to compare strings, and they'll also work on floating point or double precision real numbers as well. I have a Python program that has the majority of these examples that I just did, not quite all of them, and I will upload them with this video. And if you have questions about specific snippets of code or you're trying something and it doesn't work, just go ahead and respond in the discussion and we'll take a look. And we'll talk later.